Dr. Crafty 112 at Blue Mountain Community College. We are going to actually wrap up the last of the new material that is included in this course. This is the last chapter we're going to do. We will be talking about section views and some things called section lines. And we'll get to those in just a minute. I am going to walk through this presentation, and then I'm going to leave you to it. I'm not going to do an AutoCAD demonstration again this week, mainly because we're week 9 of the 10-week course, and it's time for you to begin figuring out how to access AutoCAD tools and techniques on your own, and understanding that there are resources out there for you to use if you get stuck. And some of those are AutoCAD books like the one we have. Some of those are AutoCAD help. Some of those are websites. There are a lot of good websites that I talked about at the beginning of the course. So I'm kind of turning you loose to start investigating the abilities of AutoCAD on your own. I do encourage you to go through the textbook tutorial in this chapter. It's got a really nice keyboard shortcut for getting to object snaps. So I encourage you to read through that. You do also have a video instructional disk that came with the textbook. So if you really are stuck, you can look through that video instruction for this chapter. So we are on chapter 10, and as I said, we're going to talk about basic principles of section views. We're going to talk about different types of section views and some of the methods we used in AutoCAD to create those. As you work through the tutorial, you will use object snap shortcuts. As I said, this is a keyboard method to get to the object snap method. And you'll also talk about changing line type scale, in other words, making your lines smaller on a given layer, and using a hatch command, and we'll get there. So let's talk first about what section views are. Section views are this piece over here on the right of this drawing, and what happens is section views are a way, this isn't a section view yet. What we have here is a front view and a side view. And I'm sure you've realized right now, because hidden lines are tricky, that we use hidden lines often, especially on round things like this part here, to visualize the internal features. But hidden lines aren't perfect. They can be tricky to use. So what we do is we essentially cut the thing in half. We don't have to cut it in half, but we cut it apart and then draw the interior. That's what a section view is. So this is an example of a section view of that same thing. Imagine that we took a saw and we cut this part right down the middle. If we did that, we would see this image we have in the right-hand plane. Now, we're not going to draw this oblique like it's shown here. We're going to do what we always do. We're going to turn it and look at this cut edge straight on. So we're going to do effectively an orthographic projection on this cut edge right here. Sorry. On this cut edge. So this drawing down here on the lower right is what we would create to show a section view. This is our top view. We visualize cutting the thing in half, and where we had hidden lines, we now have edge lines because we've cut our piece in half So what was hidden is now visible. Now we have to add something to show the which parts are solid and which parts are pieces of holes. So for example, this piece here in the middle, it's part of a hole. It's not a solid edge. But right above it, we've got the solid edge. That's where what we call section lines come in. Now, you may be thinking, well, those are just fill patterns, and you're right. When we say section lines in AutoCAD or in drafting in general, we really mean fill patterns. These fill patterns are quite often diagonal lines. Sometimes they're something different. Sometimes they're used. Different fill patterns can be used to depict different materials, and that's something that we'll talk about in a later class. So, how do we indicate where we have cut this object? You'll notice there's no indication on this drawing. There's no indication of where we cut the object. That's because this object is completely symmetrical. So each of these lines is symmetry. Could have been used as a cutting plane. It wouldn't matter which one we cut them on. That we would get the same section view. But this object, suppose we want to depict this one, and we really don't like hidden lines because they're going to be complicated, because this thing is more complicated than it looks at first, because those holes are tapered on one's end. So what we're going to do is we're going to make a cutting plane. We visualize that we take the thing and we cut it in half, right here. We draw a dash, dot, dot, dash, heavy line with arrows and a letter to indicate that we're creating a section. So this is where we're going to cut this part in half. And then we take the cut part and we turn it 90 degrees and we create this section. Okay? So this is the section view of this cut part. And you may be thinking to yourself, that doesn't look right. Well, it's because it's actually turned on its side. So this edge here, this is the top. This hole, this edge here is this hole. And what we've done is, instead of rotating it open, which is quite honestly probably what I would have done, they took this cut part and they essentially laid it over on its side. So you're looking, this is the bottom. This is this edge down here. Okay. I believe that that is correct. No, that is not correct. They rotated this open, and what we're doing is we're looking down this part. So they took this bigger part of this part of the cut piece, and they rotated it up 90 degrees. So what we're showing is this smaller hole, this hole here actually drains into this bigger hole here. So this is why we had to have a cutting line. Now, what you're also seeing is the value of hidden lines, because if we'd had a hidden line going right here, it would have been easier to see what this is. But that's what the arrows tell us as well. Okay. So let's talk about how we do this. And this slide talks about this more. Your section lines, your cutting plane lines are important because they show us, oh no, I was right the first time. Sorry, I was right the first time. They did exactly what I thought. They took this and they laid it open. Okay. What you're seeing here is how hard it can be to interpret these drawings. I'll be honest, I don't do this very often. It's been a long time since I looked at cutting planes. And I got a little confused. So pay attention here so that you can not get confused yourself. The section views, the cutting plane lines will show us what we're looking at. Effectively, what we're doing is the arrows help us understand what we're looking at. We are looking at this cut line through this smaller double circle, and we take it away, and then we look edge on along at the cutting line. So what we're doing is we're doing an orthographic projection of this remaining part along this cutting plane. That's what this section view is. If we were to cut it the other direction, cut it along the horizontal axis, we would get this view, section BB. You can include both if you need them. On this particular part, I would probably do just the BB projection, unless there's some need for this projection. But you can see how clearly this section BB shows the internal features. Okay, so let's talk about the section lines. As I said, different section lines can be used to indicate different things. They can be used to indicate different materials. Solid parallel lines typically indicate cast iron, malleable iron, or any other material that's not one of these specific ones. Steel is typically indicated by sets of narrow lines spaced further apart. Bronze is indicated by a solid dash pattern. Bronze, brass, and other composite materials. So bronze and brass are made of mixtures of metals. So are other composite materials, and so we'll use this sort of mixed line pattern to indicate that sort of mixed material. And then we use a crosshatch pattern for magnesium alloy and aluminum alloy. Now, in the construction industry, there are more section lines, more patterns that we use for other things. We'll get into that in a later class. There is an angle on these. Typically, that's 45, 30, or 60, but what you don't want to do, degrees. But what you don't want to do is you don't want to have those section lines be parallel or perpendicular to your object lines. You want them to be always at some angle to your object line so they aren't confused with object lines. That can be a real danger. You want to be very clear that it is a fill pattern. And so if there's some conflict with your object lines, pick a different angle. That 45, 30, or 60 degree angle for your fill lines, for your section lines, is not a hard standard. It's just a practice because our eyes are used to seeing those angles. Okay. All right. So back to the part we started with. You can see now that the section plane in this particular object, we're going to attach this section plane. This section, this cutting plane passed all the way through. We literally cut the thing in half, and so we show both halves. We show the whole cut edge. So we took this edge, this plane. We'll say we cut down the vertical one because it's the easiest one to visualize. And we took this right-hand edge and we rotated it 90 degrees so we're looking face on at the cut side. And this would be what we would see. Solid, and then a hole, and then solid, and then a cutout, and all solid, and a cutout, and a solid. And this piece, these parts back here, show us that the inner part of this object, where the holes are, is recessed, and we're looking here at the edges. And this shows us that the outer part, the middle part, sticks up at us in a cone-shaped fashion. All right. If you want to compare that to on page 3 in chapter 10. At the bottom left, they've got this thing shown in oblique view. Okay. Now, we don't always have to go all the way through an object. We can go just halfway. This is particularly useful for symmetrical objects, such as our part here. If you look at our cut line, our cutting plane, you can see it starts here, then makes a 90-degree turn, and then we've got the arrow to show us that we are looking end on this vertical side. So envision only taking away 1/4 of this object, and then looking at this vertical cut edge, and that's what we have shown here. You showed the lower part in its entirety. Notice we're not using hidden lines. Because we're using cutting section views to fill the normal purpose of hidden lines, we typically don't include hidden lines in section views, although we can if they would help to clarify the object. So the first edge line we see on our section view is the top of this center hole. Because if we cut through here, this part here is a cutout. There's no edge associated with it. And we know it's a cutout because we see the section lines above it showing us essentially the saw marks. These are equivalent to the saw marks that will be left when we cut the thing in half. Okay, so this is called a half section. We can also do what's called an offset section. For example, on this guy, we got lots of holes that we would like to cut through. We will quite frequently use section lines to go through holes in objects. And we've got a lot of holes here. So what we do, we can do this a couple different ways. We could do half sections and do several of them. This part is not too awful complicated. So what drafters will frequently do is do what's called an offset section. So we start over here on the left, and we go through this lower hole, and then we're going to take a 90-degree turn and go through the slot in the middle. Then we're going to come back down 90 degrees and go through the U notch. And this is the importance of cutting plane lines. It shows us what we're doing. And then we take this part and we turn it so that we are looking directly at the cut edge, and we draw the orthographic projection of that cut edge. And see, we cut through this solid bit here, and then we cut through the hole here, and then through more solid bit, and that's this, and then through the middle assembly, and that's shown here, and then through the slot. And in the section view, we can see there's a lot more to that slot than we thought. It's wider on the bottom than on the top. And we depict the hole that we don't see. We see here is a hidden line. We can also see the hidden line of the widened slot on the bottom. So these hidden lines actually add value in this drawing because it helps to orient us on our section view. Okay? Now you'll notice that this piece, this edge of this U slot, is not shown filled. That's because we didn't cut this edge. We cut through the U slot, and we did not cut this edge. So you only use your section lines where you would cut through the material. And so that means where you would leave saw marks if you were using a saw. Notice that these section lines tell us something about this thing. It's made out of steel. Right? If you go back and look at your section lines and what different fill patterns mean, and those are on page 5 in your textbook. Okay, we can also just essentially cut out a chunk. So envision your dog coming up and taking a bite. That's what this is. This is a broken out section. Sometimes it's not necessary to do a full partial section view. Sometimes we can just embed the section view in the orthographic projection. That's what a broken out section does. You use kind of just a wag, kind of a wavy line. So this is almost like a hand-drawn curve, showing that you're breaking off a section of the front of this thing. And then you're just going to show the internal features right within that broken out section. Now, this is mostly used for cylindrical objects because they're symmetrical, and typically, like this one, where it's got a gasket part, you use the broken out section to show the details of the interior. What section views do is they take hidden lines and make them visible, making things a little bit easier to see. Okay, we can also do what's called aligned sections, and aligned sections work just like the half section, except you don't go at 90 degrees, you figure some other angle. It's almost like a partial offset section. Now, this is used most frequently in circular planes to show objects in their true radial position, because if you think about cutting along this line, you're going to see that this hole is on the same circle as the upper one, even though they're not perpendicular one another, because this is a 5-hole pattern. So sometimes we will cut on an angle, go through the radius and then cut, and on a different radius. And again, this is the value of the section lines they show, or the cutting plane lines they show us where we cut, so that we can relate our section value to our orthographic drawing. Okay. Sometimes, when space is limited, we will, on symmetrical parts, only show half of the actual object. Now, we're only showing half of this. That would indicate, you gotta be careful here, because this would mean we have a 6-hole pattern. If we only show half, then we are telling our viewers that the other half looks just like the half we are showing. And you can either do then a half view with a full section view, or a half view with a half section view, depending on what's going to be most useful for you. Sometimes we don't have to do a full cutting plane. Sometimes we can just take a section and revolve it to show our piece. So take, for example, this wrench. We could do a cutting plane right down the center, but we don't really need to, because we can just do our orthographic projection and then take one piece of this square part and turn it 90 degrees and show it as if we had cut it out. And this is useful for showing the profiles of simple objects like this wrench. There's 2 different ways you can do it. You can either just take it and turn it 90 degrees and put it in the object. Actually, there's 3 ways. This is my preferred method. It's more obvious to me what's going on. And the way that you make sure that we know that this is a section drawing and not a hole in the object is with your fill lines. If you leave out your section lines here, this will look like you just cut a hole in this thing. Like these are edges, and either they're holes or they're projections. And it won't make much sense, because you can see on the other view that that's not the case. Excuse me. So these section lines are important to tell us that we are looking at the internal aspects of this object. What they're telling us here is that this is a square cross section up here made of steel, and down here we've got a hex. Wait, octagonal. This is an octagon key. Yes. So you can either superimpose them this way, you can actually use break lines to separate out the part, or you can put them above. And my personal preference, and this is strictly my personal preference, is either this one, where we show clearly by separating that we've taken a set of the part of the thing and turned it around, or doing it up above. But all three of these depictions are correct. And you can do the same thing for, so the other reason this can be useful is for complicated fasteners. And that's really what this guy is. We've got the counter bore down here, and then we've got some complicated stuff going on. So this is a solid head. And I know this is a solid head because these are all hidden lines. And these hidden lines actually indicate parts of the threading and this little counterbore fit back here. Now, the easiest way to depict this counterbore bit here is with a section view, because he's going to be hard to show any other way in sufficient detail. So what you can do is you can do a side view, you can do a top view, and then you can do a cutaway section on your top view. That's what we've got here. All right. There are different ways to make breaks in drawings. We've been looking mostly at rectangular sections. So with rectangular sections, we just use this wavy line, unless we're looking at wood. And then we show it as if we had broken our wood. And so we show jagged splinters. Now these are break lines. They're different than cut lines. Remember, break lines are used mostly for the broken out section or for the rotated section. When we're talking about cylindrical lines, we tend to use S's. And that's really what this is. If you look at this cut line, it's an S. And you can show either solid or hollow with your S. It kind of gives you a three-dimensional effect. Okay. Ribs and webs are shown pretty much the same way as everything else, but you want to be careful to avoid misleading things. So you want to, or misleading your viewers, because it can be easy to do unintentionally. You always want to section through your ribs. Okay, so be sure and follow these conventions. It's what practice has shown to be the most clear. Okay. You can also do thin sections. But if you are looking at really thin things like less than 3 millimeters, that's almost the line of your section, the thickness of your section lines. So we generally don't put in section lines. And if parts don't have any internal features, don't section them. If there's not something you need to show it is in the section, don't do that. Just use standard orthographic projections. Okay, so your activity for this chapter is this bearing. And the chapter is going to walk you through creating an orthographic projection and a section view of this object. First thing you're going to do is draw the orthographic projection, and it's in the creation of this top view that you use the shortcut, keyboard shortcut, to get to the object snaps, because this is created with, first you draw three circles. You draw this circle for this curved edge, and this circle for this curved edge, and then you draw this outer middle circle, and then you draw 4 lines that are tangent to those circles. And right now, you know there's more than one way to create any object. This is how the textbook walks you through that, so that they can show you how to get to object snaps on the keyboard without having to go to the object snap menu. And then you're going to do a standard side view of this object, complete with your hidden line. So this will be the first thing you do. You'll create the standard view. And this is how in AutoCAD we create section views. We start with the standard views, and then we put in our cutting plane. And then what we do is we take our side view and we take our hidden lines, and through the beauty of layers, we turn those into edge lines. Now you're not quite done yet, because this doesn't look like a section view yet, because it doesn't have any section lines. So you haven't indicated what's solid and what's a hold. Now we know what we started with, so we kind of know, but we really need to indicate that. So then you add section lines. Yeah, section lines are added using the hatch command that's in the drawing area. So, and you'll need to look at how to pick the points to indicate what needs to be hatched. All of this is clearly shown in your textbook, so I'm going to lead you to it. And then I want you to make a drawing port and put this thing on a drawing with dimensions as if you were going to plot it. So do use your layers appropriately for your center lines and your dimensions. When you're creating this thing, you're going to use construction lines. Please turn off your construction layer before you submit, before you save your drawing for final submission. You would not ever put a drawing out on a user, on a server to be used by your engineers with construction lines turned on, so please do turn that off. All right, good luck, enjoy, and I will see you all again soon.